Hi, today we are going to do algebraic vector addition. When we're doing vector addition, what we want to be doing today is adding together vectors using mathematical means such as trigonometry to get very precise answers. The last video we did, we saw vectors being added together graphically. If you didn't see this, make sure you see this first. We're actually going to do this same exact problem here today. But to do this problem, what we need to make sure we do is know how vectors work and be able to find their components. So to find a component of a vector, we are going to use trigonometry. So if this is a vector, I'm just going to draw a basic vector here. Let's say this vector is represents 50 meters at an angle in polar coordinates, 0, 90, 180, 270. Let's just say that we are at an angle of 40 degrees. This vector has both an x and a y component that get to that point. And what you can think of an x and y component is a line that goes only in the x direction and a line that only goes in the y direction. So we have here a triangle that we've created. So this vector, this line, represents how far x-ward we go, and this line represents how far y-ward we go. Some people talk about you making shadows. If you were to have a bright light, let's say up here, shining down, this would be the shadow of the line. If you had a bright light over here, shining this way, this would be the shadow of the line. But it is how far x and y you need to go. Another way of thinking about this is if somebody said to you, go 5 meters at 30 degrees or 50 meters at 40 degrees, and you said, oh, I can only move left and right and forward and backwards. Give me the directions for that. That's what this is giving us. Now, you could see here that this vector has it has an angle and a hypotenuse for a triangle, and therefore we can use SOHCAHTOA to be able to find these values. If you go back to the video that I talk about where sine, cosine, and tangent come from, I mentioned to you that this idea of the chord and this idea of the coordinating sine function. So you would end up seeing that this value down here would be cosine, this would be sine. That is true, but that's a little abstract for you probably at this point. Just thinking about this as SOHCAHTOA is all we need. So if we know the hypotenuse and I wanted to find the adjacent side, that's a cosine function. So to find the length of this side and to find the length of this side, I would have to use cosine and sine. So the cosine of 40 is equal to the adjacent x over 50. And so 50 cosine 40 is equal to x. And then the same thing happens for y. You would have 50. You would end up saying, we actually did this, you would say the sine of 40 is equal to x over 50, and then you multiply both sides by 50, and you would say 50 sine 40 is equal to x. And you would plug that into your calculator and get the values, and that would represent the length of x and the length of y. It is true that 50 cosine 40 squared plus 50 sine of 40 squared, take the square root of that, is going to equal r, because 50 cosine 40 represents the x length and 50 sine 40 represents the y length. And so basically you're saying x squared plus y squared is equal to r, and that does work out as well. Now, once you're able to find the components, you're able to do what we're going to refer to as vector addition, algebraic vector addition. And here's how it goes. Step one is going to be to write down the values. If you look back in the other video where we did this graphically, you will see that we had 150 at 300 or 30 degrees. We had 100 at 110 degrees, and we had 120 at 300 degrees. We don't need to scale here. What we are going to do is we're going to make what I'm going to refer to as a vector table. So a vector table is going to divide this up into its x and y values. And so to find the x value of this, to find the x value, you will always use r cosine theta. That comes from this idea here. You ought to find the y value, you will use r sine theta. And so you start plugging these into your calculator. 150 cosine 30, 150 sine 30, and so on and so forth. So 150 cosine 30 is going to be, I'm going to round these to the nearest whole number. So I'm going to say this is 130. And so there is some error because I'm rounding. If we let the computers and calculators take this out to more decimal spots, there will be less error. So it is not as precise as doing this on a computer or calculator where it's going to be able to take this out further, but it is definitely going to be more precise than drawing it because there's human error, there's the width of the lines, things like that. So you have 150 cosine 30, 150 sine 30, which is just half, so that's 75. You have 100 cosine 110, which is going to be negative 34, and you have 100 sine 110, which is going to be 94, and then you have 120 cosine 300, which is 60, and then you have 120 sine 300, which is going to be negative 103. Actually, it's negative 104. So when you are doing this yourself, you are going to definitely want to take this out to at least the 10th spot. Depending on the numbers you're dealing with, you may even want to take it out to the 100th spot. I'm rounding here to the whole number just so that we can see it nice and big here on this paper in front of us, and we get the process down. I don't want to confuse it. So what we have done here, and I think it's always important to draw yourself a quick picture to validate what it is you're doing, is we are adding together the 150 at 30, which is approximately that way, and the 100 at 110, which is approximately that way, and the 120 at 300, which is approximately that way. And so what we just found is the x value for the first vector, and then the y value for the first vector. This would be 130, and then this is 75. Then we have here negative 34 and 94. That's the second vector. They're the values that are right here, negative 34 and 94. And then we go 60, and we go negative 104. So our picture seems like it matches our numbers, which is a good thing. The numbers really need to match the picture. So when you draw this quick sketch in your mind, you're thinking, okay, 30, 110, 300. That looks about right to me. And so these numbers don't seem to have error. If you draw the picture and you get a negative here and it looks like it's positive here, then maybe you plugged in the wrong value. It's a good way of doing a check. Draw yourself a quick picture, make sure that it makes sense. It doesn't take long. I say to students, if you spend more than 10 seconds drawing the picture, then you probably are putting too much detail into it. You should be able to go really quickly through drawing 3 vectors. Just think about, okay, it's 30 degrees with a certain length. Okay, this one's a little bit shorter at approximately up and to the left. This one is a little bit longer at approximately down and to the right. Boom, and it matches. So once we've done that, now we need to add together all of the x's, because our resultant, our final resultant here, is going to represent the line from our start point to our end point. And so we have already drawn this with our protractor by saying, okay, that's That's a line that's about that long, and we draw it out. Go back, and you can see us going through this whole process. But in this case, we ultimately want to get the X and Y values of the purple line here. And so the X values are going to be the length of a line this way, and the Y values are the length of the line this way. And so to find the actual length of X, we are going to add together our 1X, subtract the second X, add again the third X. If we add and subtract our X's, we end up right there. And then the same for the Y. We add a red line, we add another red line, we subtract a red line. Those numbers are right here in front of you. So we just take our calculators and we add 130 plus 34, minus 34, I should say. It's plus negative 34, plus 60. And we end up with, when we do that, 156. So this is 156. So 156 is the length of the green line. And then 75 plus 94 minus 104, that's 65. That is the length of this red line right here. And so these values, 156 and 65, represent the components of the resultant. Each of these values up here represents the components of their individual vector. So the 150 went 130 on the X and 75 on the Y. They're negative 34 and 94. Get the idea. So to find the resultant length, the length of that line right there, what you want to do is recognize that you have a right triangle created here. It's right here. This is your right triangle. Right? That triangle there, sort of in black now on your screen. And that triangle's length can be found, because we know this is 156 and this is 65, by doing the Pythagorean theorem. So R is going to equal the square root of 156 squared plus 65 squared. And so the value of R ends up being, when we plug that into our calculator, R is equal to 169 meters. Original values were in meters. And then our X values, or our angles, our angles, we are going to recognize that we're solving for this angle right here. And so it's opposite over adjacent. It's going to be the tangent. So it's the tangent inverse of Y over X. So it would be 65 over 156. And that would be 22.6 degrees. And so that is the very precise value that represents our vector sums. And if we go back to our original graphical, we said 166 at 23, plus or minus 5%. So when I take 166 and I multiply that by 0.05, 166 times 5%, that's 8.3. So 166 plus or minus 8.3, 169 falls in that range. So actually, going back to our original number, we should be doing this based on the actual number. I actually said that backwards here. So it should be 169 times 0.05%, or 0.05 or 5%. And that value should be a little bit bigger, actually, because it's 3 units bigger. So it's 8.5 actually now. So 169 minus 8.5, 169 plus 8.5. Our original 166 fell in that range. So you would say that graphically we did it right, and we did it this is the answer algebraically. So this is the right value. We're just finding if our graphical way worked. And then the second thing is the angle. And so when we do the angle, what we find is that it's plus or minus 3 degrees. So 22.6 minus 3 is 19.6. Plus 3 is 25.6, and our value is 23 over here. So 23 is the correct answer. So when you're looking at this, again, make sure that you recognize that we are looking at this value, the algebraic sum. This is the value. This is the correct value. We compare the correctness of the graphical method to the algebraic, and we can see here that we did it correct both ways. One other modification that we need to be aware of is that not every resultant falls in the first quadrant. The resultant we got this time was in the first quadrant, but the resultant could be in the second quadrant or the third quadrant or the fourth quadrant. And so when we take the tangent, you probably remember this, the tangent of, and we'll use the numbers we had here, the tangent inverse of, it's always y over x here, so that would be the tangent inverse of 65 over 156. We get, again, 22.6. But when we take the tangent inverse of negative 65 over negative 156, that would be this vector down here, negative, negative, third quadrant, we also get 22.6. Uh-oh. Why is that? Well, the calculator's not too smart, and it doesn't know the difference between two positives being divided and a negative. That's where your brain comes in to say, we got to take into account that this is in the other quadrant. We look at our resultant. If our resultant, which can be seen from these values right here, if our resultant is first quadrant, positive, positive, second quadrant, negative, positive, third quadrant, positive, negative, fourth quadrant, negative, negative, depending on what we have there, we do have to modify this tangent function. If we are in the first quadrant, we add 0. If we are in the second quadrant, we add 180. If we're in the third quadrant, we add 180. If we're in the fourth quadrant, we add 360 to the reference angle, whatever value we got here. We were in the first quadrant here, so we are not adding anything other than 0, so the number's not changing. But in this scenario I have over here, I am in the third quadrant, so I would need to add to that, going back to the chart, third quadrant, I need to add 180. It's a plus 180. And so we add 180 to this, and that gives us a new angle of 202.6. And so that is how we make that modification. This chart right here is very important. This chart right here. You want to know that chart and know what to do with it. If you have, again, depending on which quadrant you're in, you change the angle by this amount. If you have any questions, let me know. As always, have a great day.